Yes, allow me to take you through indices. Let us go to indices. It is a new topic: indices, logarithms, and surds. So specifically today, let us look at indices. That we begin by saying consider a to power n. This is read as a raised to power n, i.e. a is the base and the n is the power. We all know this from primary work. Now, the term power is also known as the index, and the indices is the plural form of index. So here you can clearly see where the term indices comes from. When we have more than one power, we don't say indexes, rather we say indices. So when you come to indices here, we are going to see how to simplify indices. And if we are to simplify indices, we need to learn some laws of indices. And the first law of indices is this one here. During multiplication of indices whose bases are the same, like for example a power n times a power m, what we do, it will be equal to a to power. We add the powers. We write the base, which is a, and then the powers we add them, because we are multiplying indices whose bases are the same. That's the first law. Then the second law, it is during division. When we divide indices whose bases are the same, we just subtract the powers. For example, a to power n divided by a to power m is equal to a raised to power n minus m, the power of the numerator minus the power of the denominator. That's the second law of indices. The third law of indices, that is a to power n, still raised again to power m. So these two powers, when we open the brackets, they have to multiply each other, i.e. that is a to power n times m, and therefore it is the same as a to power nm. So, and then the fourth, it is a to power 0 is equal to 1. Any number to power 0, it is always equal to 1. So here we have some of the laws of indices. We shall look at more, but basing on these ones here, we can be able to look at some few examples on them. So like the first example here, use the laws of indices to simplify the following. So we are going to simplify some numbers here, but using the laws of indices. So the first one, 3 times 3 times 3. So when you go to solution, 3 times 3 times 3, all of them are raised to power 1. There's a silent powers on them, which is not indicated. So using the laws of indices, the first law of indices, when we are multiplying indices whose bases are the same, we simply add the powers, and therefore here the answer is 3 to power 3. The second example here, it is 4 times 4. But remember that I've said we have to use laws of indices. So 4 times 4. 4 is the same as 2 squared, and again there we can be able to see that we are having 2 squared times 2 squared, and still we are multiplying indices whose bases are the same, so we add the powers, so which will be equal to 2 to power 2 plus 2, which is equal to 2 to power 4. That is the answer. You leave it in that form. That is the answer to part B. Then part C, the solution to part C, we have 6 times 6 times 2 times 2 times 2. So these ones here, now still when you come to 6, there are two factors there, which is 2 and 3, prime factors. So we can separate them. That is 2 times 3 times 2 times 3 times 2 times 2 times 2. So still here we collect the like terms, those bases which are like